Okay, today we are finding limits graphically and numerically. So when we find limits, we're trying to find the y values as x approaches a particular number. So when we have a function, we can do it numerically or graphically, depending on what we're given. If we look at the graph here, this says to find the limit of the function as x approaches 1. So we're going to look at each side as x approaches 1 and find out what the y value is. So as this function gets closer and closer and closer to 1, if we look up here, then we see that it is approaching 3. It's getting closer and closer to 3 on the y-axis, or the y value. Same thing from the right. If we approach this from the right, and this thing is getting closer and closer and closer to 3 as the y value. Therefore, the limit of the function as x approaches 1, the value of y gets closer and closer and closer to 3, or the value of the function gets closer and closer and closer to 3. So you can do this graphically or numerically, and you will see the limit notation written as such: the limit of a function as x approaches some number c. Capital L stands for the limit. So if we have this function here, the limit of x squared minus 3x plus 2 all over x minus 2 as x approaches 2, then we can either graph this and look at it from the graph, or we can find our solution numerically. Now, one thing to note here is that there's a hole in this graph, because if we factored x squared minus 3x plus 2, that will give us x minus 2 times x minus 1 all over x minus 2, and the x minus 2's will cancel, so that tells me that there's a hole at 2. Okay, so that's okay. Alright, and let's, just for time's sake, you could plug these into your calculator and come up with your calculations, but let's look at 1.99. If we substitute 1.99 in for x and simplify, we would end up with 0.99. If we substitute 1.999 in, we would end up with 0.999. Now, if we come from the right, substitute in 2.01, we would end up with 1.01. 2.001, we would end up with 1.001. And as you can see, as we approach 2 on the x-axis from the left and from the right, we get closer and closer and closer to 1. Now, this is undefined, and that tells me, again, that we have a hole in this graph. You can look at that. But as this approaches 2, x approaches 2, then my limit is going to be equal to 1. So my limit of this as x approaches 2 would equal 1. That's what it gets closer and closer and closer to. Okay, so let's look at a few more of these graphically. So we want to find the limit as x approaches 3 of 4 minus x. So again, as x approaches 3 from the left, we look up here. As it approaches 3 from the right, we look up here, and we see that as x approaches 3 from the left and from the right, then the y value is 1. Therefore, the limit of this function is equal to 1. Okay, what about the limit of the absolute value of x minus 2 over x minus 2? So if we graph that, our graph would look like this one here. So as x approaches 2 from the left, then we're up here at positive 1. As x approaches 2 from the right, we're down here at negative 1. Now, since this has two different values, as x approaches 2 from the left, it approaches positive 1, but as it approaches 2 from the right, it approaches negative 1. Therefore, since the limit approaches two different values, our limit does not exist. It has to approach one value, the same value from the left and from the right. Okay, this one here, we have the limit as x approaches negative 4. I should say the limit of sine x, sine pi x, as x approaches negative 4. Okay, so as x approaches negative 4 from the left, we see that the y value is 0. As x approaches negative 4 from the right, we see that the y value approaches 0. Therefore, the limit would be equal to 0. Okay. What about the limit of 2 over x minus 5 as x approaches 5? So again, we look from the left and we look from the right. So from the left, as x approaches 5, this graph shoots up and it keeps going up to positive infinity. However, when the graph approaches x from the left, this thing goes down and keeps going down, and it goes down to negative infinity. So again, it approaches two different values and actually doesn't approach a value at all. It continues to go up and down, so the limit does not exist. So again, this approaches infinity and negative infinity, and since it approaches infinity, period, then it does not exist. Okay, let's look at this one here. And again, we're trying to find the limit, decide whether the value exists, and if it exists, tell what it is. So here we're not just doing the limit, we're actually going back to a little bit of algebra, finding f of 1, which means when x equals 1, what is the value of y? So here, when x equals 1, the value of y, you can see we have a solid dot here, is 2. Now it's a little bit different. The next one, it says find the limit of the function as x approaches 1. So again, you have to look from the right and from the left. So when x approaches 1 from the right, this thing is going down to approaching 1, approaching the y value of 1. However, when x approaches y from the left, this thing is approaching about 3.5. Therefore, since it approaches two different values, then the limit does not exist. Okay, find the value of the function when x is equal to 4. Well, when x equals 4, we have a hole here, so we don't have a value. Now, it could approach a value if we were finding the limit, but we don't have a value there when x is equal to 4. So, no solution, or it does not exist. Now find the limit of the function as x approaches 4. So as x approaches 4 from the right, here, as x approaches 4 from the left, here, we see that the y value is equal to 2. Now again, we're just looking at what it approaches, so there can be a hole there, that's okay. We're not trying to find the value of the function, we're trying to find the number that it approaches. And since it approaches 2 from the right and the left, then the limit of the function as x approaches 4 is equal to 2. Okay, I hope you found this video to be helpful. Thank you.